In this video, we're going to go through Learning Target 331, which is the 3.0 level for solving systems of equations. And so the only difference between the 3.0 level and the 2.0 level is that you are going to be able to choose which method may work best or which is appropriate for the given question. And so we're going to go through a little bit of notes and then we'll go through some examples as well. So our first step is to determine which method may be best for the given system. And then in parentheses it also says, or which one you like the most. So step one is to determine which method may be best or which one you like the most. And the only reason we say that is that for some people it makes the most sense to do elimination every single time no matter what, because that's what they're really good at. For some people, it makes sense to switch back and forth depending on what the problem looks like. Remember that if you need a second to write this down, you can pause it in between each set of notes. Step two is to manipulate one or both of the equations to be able to use the method. So let's say we want to use substitution. We need to make sure it's set up for substitution, so we need to get one equation to say x equals something or y equals something. So we need our equation to say either x equals or y equals, and it doesn't matter which one you do that for. So if there's one that looks like, oh, it might be easy to make this say y equals, you can do that one. It doesn't matter which one says it. But if we're using elimination, we need to set that up differently. So if we're using elimination, we need to get the x terms or the y terms to be able to cancel. And the way we do that is it needs to be opposite numbers. So 2 and -2 is an example. So elimination, we need to set it up so that when we go ahead and we add, one of our terms, either the x's or the y's, eliminate. And then our final step is just to do that. So once we kind of manipulate and once we get it to be set up correctly, then it's the same as the 2.0. Solve using the same steps as the 2.0 and write your answer as a point. If you don't have all these notes, pause it and make sure you have everything written down, and then we're going to do this example together. So this one says to solve the system given. And we see here that we don't quite have anything set up for substitution. The top one does not say x equals or y equals, and neither does the bottom. We also don't quite have this set up for elimination, because elimination we need to either have the x's cancel, which the x's won't, 2 plus 1 is 3, or the y's cancel, and these won't, 2 plus -3 is -1. And so neither of these are set up correctly, so we get to choose. And you can choose what makes the most sense for you or what's easiest for this problem. I'm going to go through both. And this one is actually really interesting because it's a perfect example of when it's equally easy to do both of these. It doesn't really matter which you choose. And typically if you were in class, Ms. Glefke would show you substitution because she prefers that. And I would show you elimination because I prefer that. But we're not together, so I'm just going to do both. But for substitution, my goal is that I want x equals or y equals. And so what I'm looking for is a way to easily get x or y by itself in either of the equations. And so hopefully you notice in the second equation, x does not have a coefficient. And so all I would need to do to get x by itself is get rid of this minus 3y. And so I'm going to do that. So if I have this original equation, to get rid of minus 3y, I can add 3y. And I get x equals negative 1 plus 3y. Now I have a perfectly fine system of equations to use substitution. I have x equals, so I can use this one and substitute it into the other. Just be very careful you don't accidentally substitute it into itself. So I used this bottom one, so I'm going to bring the top one down. And now this is set up just like the 2.0 would have been previously. We take our piece that's equal to x, and we plug it in. Since it says x equals, this is the same as x, so I can plug it in for x. So I get 2, and then in parentheses, everything inside of that box. Then I'm going to finish out this equation, and we have our substitution set up. Now I want to start simplifying this, and so I want to distribute and multiply. So I get negative 2 plus 6y, and then the rest stays the same. Now I notice that I have like terms on the same side, so I can just combine them to be 8y. Between these two, this one is a like term with negative 18, so I want to get rid of it by adding 2. And then I get to divide. So I'm left with y equals negative 2. And so we know that this is not our answer. This is only half of our answer. And so we need to take this and plug it back in to one of our originals, or this one that I manipulated. It's up to you what you plug in. This one that says x equals, is definitely the easiest to plug in. So I'm going to plug it in there. So I'm going to take this negative 2, plug it in for y. And I can type that whole expression into my calculator. So I have negative 1 plus 3 parentheses negative 2, which gives me negative 7. And so my final answer is negative 7, negative 2. So now you can pause it if you don't have these notes, but I also want to show you elimination, because you could do this problem with elimination as well. And so for elimination, we're not quite set up either. However, to kind of manipulate our equations, we ask ourselves what we want to get rid of. And so we kind of figure out, if this is a positive 2, to get rid of that positive 2, we would need this to be a negative 2. And so I can multiply my entire equation by any value to make it so that I can get rid of the x's or the y's. And you kind of just want to do whatever is easiest in that problem. So in this problem, it's easiest to multiply by negative 2 so that this becomes a negative 2 and these cancel. If you tried to get this 2 to become a negative 3, you would have to multiply by a decimal, which isn't very simple, so this is probably your best bet. And so you're just going to multiply every single piece by the value you want. So we got negative 2x plus 6y equals positive 2. And now I'm going to bring down this one that we didn't touch so that it's lined up and set up for elimination. And now you can see these are going to cancel. So for elimination, the biggest mental piece you have to do is figure out what you need to multiply by so something will go away. And I'll usually look at the x's and see what that is, and then the y's. And remember, we need them to be the same number, but the opposite sign. Once you have it set up, this should be a review of elimination. We add up and down. So we get 8y equals negative 16. Y is negative 2, which makes sense because that's what we got over here. And then we plug it into one of our equations from the original. And we get x is negative 7, which is the same answer. So I know this was a little bit of a longer video, but I hope it helped for you to see both versions. And like I said, you can choose whichever makes the most sense for you. So if you like substitution or elimination better, you can choose that. Or based on the problem, you can switch it up and sometimes do substitution and sometimes do elimination.